Hey, this is ChronoAB, and in this video we're going to learn how to make wall jumps in Unity 2D. So we are going to start by making something like a wall slide, right? And then we'll end it by making a wall jump. So with that said, let's get started. So this is a normal scene with a player where we have a movement script that helps with our movement and jump. Let's just open that in. So this script, you can just download it from the link in the description, or you can download the whole thing from the link in the description so that you can follow along pretty easily. So now let me just give you a little bit of information. The information is these four values help us move the player and flip the player, as well as control the animation of our player when it is moving. So if is moving is true, animation will play, otherwise animation won't play, moving animation won't play. These 4 lines of code help us check if you are grounded or not, and if you are and you press the jump key, that means your can jump will be true, then you will jump with some amount of jump force. This is the reference to the animator and the rigid body of our game, of our player basically. Here in the input, in the X directional input, we put the horizontal controls, and when we press the jump key, then can jump will be true. In the checkboard, we check if we are grounded or not by creating a box on our ground check point position and with a ground check size, and this ground check position and size, this box basically checks for our ground layer. And if we do touch the ground layer, grounded will be true and we can jump. Now this here, if we just press the left or right key or A or D key, meaning if in X directional input is not equal to 0, then we can play the movement control, movement animation, otherwise we won't play the movement animation. This line of code just helps us move the player, as you can see, and this helps us flip the player. This function just helps us flip the player. This function helps us jump when we press the jump key and we are grounded, that means we can jump, and these two help us play the animation. So if according to this is movement boolean, this is movement or this movement animation gets played, and according to this grounded boolean, this jump animation gets played. And this just helps us create the box on our scene. So if I just click here, as you can see down here, this has helped us create a box, and this box helps us see if we are grounded or not. Now let's hit play. So as you can see, I can move, the movement animation plays, I can jump, the jump animation plays. Does not look that good, but you get the point. So now let's make our wall slide. So up here, let me just copy this header, put it down here, and instead of is jumping, right, is wall sliding. Wall sliding. Now here we need, first of all, say serialized field float, and we need a wall slide speed. Wall slide speed, we can just set it up as 0, and then we need exactly these 4 things, or literally the same thing as these guys. All right, so if I want to, I can just copy and paste it here and just change the names to wall, and we literally are going to do that. So let's say serialized field, right, layer mask, and let's call it wall layer. So wall layer. Another let's say serialized field transform wall check point, and lastly serialized field vector2 and wall check size. Now we also need these 2 things. One will check if you are grounded, and one will check if you're touching the wall, and the other will check if you are sliding on the wall or not. So let's do that. Private boolean is touching wall, and another private boolean is wall sliding. So now let's just set up our is touching wall. So in our check world function, let's just go here. Literally you can just copy and paste it and just change the variable here, and you can just do that, but I'm going to show you. So is touching wall is equal to physics2d dot overlap box, do the same thing, and now instead of ground check point for our vector2 point, we'll use wall check point dot position. Instead of ground check size, we'll use wall check size. For the angle, 0, and instead of ground layer, we're going to use a wall layer. So once we do that, let's just hit save, go back to Unity, and now you can see other things here, wall slide, which layer we are going to check, right? What do you call this, wall check point, and the size of our wall check box. So for the wall check layer, we're going to use wall, right? The reason why we're using wall and ground is because for the ground, for all of these grounds that I have made in my tile map, I have set them all to ground, and for the wall I have set them to wall. You can just add a layer, whatever layer you want, and just press enter and you'll have that layer, and you can just set it up as that layer like this. So let me just put that back to wall. All right, in here we are going to check for the wall layer, and the thing that is going to check for the wall layer is my wall checkpoint. I have already put it in front. Just put it in front of your character. All right, so I have already put it in front, and let's just drag and drop it here. Then for our wall check size, for now let's just keep it both of them as 1. And now the reason why we can't see anything here is because we have not done this. We have to set the gizmos for this guy as well. So let's just do that. Let me just copy this because it's the same thing as I said, and let's just do that. So for wall check, for ground. All right, for ground check, for wall check. And now this is blue. Let's make this color of this gizmo as red. And now instead of ground checkpoint position, let's have wall checkpoint position. And instead of ground check size, let's have wall check size. Now after we do that, let me just hit save, and as you can see, now we have this box. Now let's set that box up. If I put like 0.05, it just looks perfect, right? Now this guy will check if we are touching the wall or not. So let me just hit play. Right now it's touching wall is false, and because we're touching the ground is ground, it is true. So if I go here and touch the wall, now it's touching is also true, which is great. Now let's make a function called down here, just below our jump. Let's make a function called wall slide. Let's make a function called wall slide. And now for us to wall slide, we need to like match some amount of condition, which is if we are touching the wall and we are not grounded, and we need one more thing, which is called and rb.velocity on the y-axis is less than 0. So meaning if we are touching the wall and we are not touching the ground and we have started falling down while we are touching the wall, then we will do some wall sliding. So here, right, is wall sliding is equal to true, else is wall sliding will be equal to false. Now for wall sliding, what we need to do is if we are wall sliding, that means is wall sliding is true, change the velocity of the player on the y-axis. That means like this, rb.velocity not dot is equal to new vector 2, and we won't do anything on the x-axis, so rb.velocity dot x, because we're not going to change anything on the x-axis, but on the y-axis its velocity will be our wall slide speed. So now once we do that, if we have to, first of all we have to just make a reference to this. So let's go up in our fixed update, because everything related to physics will be kept and should be kept in the fixed update. So wall sliding. All right, now once we have made the reference, let's just hit save, go back, and now let me just put it to normal. Now wall slide, I'm not going to put anything here, I'm going to tell you why. But if you want to put something, put a value between 0 and 1. all right. I think minus value will also work, but don't put too much, otherwise it will start sliding too fast. All right, don't put a value above 1, because that will literally make you go up instead of down. So let me just show you. If I put 1, then that's the most wall sliding, most slowest wall slide you can ever have. Right, that is too slow. If I put it as 0, it's actually fairly good. Right, if I put it as, let's say, if I put it as 2, what's gonna happen is we will literally start going up. Yeah, so put a value from basically 1 to about minus how much you want. If you take it to like minus 2, what's gonna happen is it's gonna actually start like going down even faster. As you can see, it is wall sliding, but it's way more faster, right? So the sweet spot for me is actually 0, so I'm just going to keep it as 0, and I just have a good wall slide. So now let me keep it as 0. So now wall sliding is done. Let's add some wall jump. Let me just copy this header for wall jumping. Now first of all, we want a jump, or let's say wall jump force. So serialize field, float, wall jump force. Then we need the direction on which we will jump. Let's say you are facing left, right? You're facing right, let's say, and you just touch the wall. When you hit the jump key after you are on the wall, it should literally move backwards like this. So we should have a negative position, right? We need a wall, basically we need a wall jump direction basically. So right, float wall jump direction. So a wall jump direction, and then this we need to make our player jump at a certain angle. All right, this value we need to make because we want the player to jump at a certain direction. So for that, let's say serialize field, float wall jump angle. Oh yeah, by the way, it should not be a float, it should be a vector 2. According to this vector 2, we'll jump at a certain angle, right? According to this, we'll jump at a certain direction, and according to this, we'll jump at a certain force. So for the force, let me just set it up as 18. For the jump direction, because we're facing right, we need to jump in the opposite side. So let's keep it as -1. And the jump angle, we'll set it up in the inspector. So now, first of all, whenever I am moving or whenever I'm flipping, this value should also change. So in our flip function up here, just write wall jump direction and multiply it by -1. So now every time I flip, what's going to happen is whenever I'm on the right side, it will be -1, right? Whenever I flip on the left side, what's going to happen is this value will turn into +1. That means if I am facing left and I climb the wall and I do a wall jump, that means I will jump on the right side. So that is why we need the wall jump direction. Now let me just do a wall slide. Below this wall slide, we need another function called wall jump. So here what we need to do is, if we are wall sliding, we are either wall sliding, or even if we are just touching the wall, then we can wall jump. Got it? So if you're wall sliding, or and put it inside another bracket, all right? So if you're wall sliding, or let's say you're even just touching the wall, then you are able to wall jump. But you should also have to press the space key. That means can jump should also be true. So if you are either touching the wall or just sliding on the wall, and you press the jump key, as you know here, let me just show you. Yeah, when I press the jump key, can jump will be true, then you can wall jump. So first of all, you can wall jump. All right, and after you wall jump, your can jump should be false. All right, your can jump will be false. So now what we need to do is we have to add force to our object to make it do a wall jump. So for that, write rb dot, not velocity, add force, not angular drag, add force. So rb dot add force, a new vector 2, and on the x-axis we need to write wall jump force which will multiply by our wall jump direction, and that will multiply it by our wall jump angle on the x-axis, because this is the x-axis. For the y-axis, do the same thing, right? Wall jump force and multiply it by wall jump angle. But we won't put the direction because we don't have anything to do with direction on the y-axis. Wall jump angle on the y-axis, by the way. So once we do that, here we need to specify what kind of a force it will be. So force mode 2D dot impulse. So basically, let me just show you, we have put a force on this angle basically, with some amount of force on a direction with an angle on the x-axis and some amount of force on the angle of y-axis. So once we do this, our wall jump should work. So let me just make a reference to it in our fixed update function. And once we do that, if I go back, and now the wall jump is good. The direction, actually we should not be seeing that in the inspector, but for now you can know what's going on here as well. For our jump angle in the x-axis, now to have a good jump, what you should have is there should be more height than the width of your jump. That means on the x-axis put 1 and the y-axis put 3. Now when I hit play, first of all look at this, alright, because we're facing on the right, it's -1. When I start facing left, it will be +1, and that just helps me do a wall jump on the right side. So after that, let me just do this, okay, but as you can see, when I press the jump key, it just goes straight up. Now the reason is because of this thing. This should only affect the angle of our jump. This should not affect the force of our jump. But what's happening here is that because x is 1, so the force on the x-axis is just 18, but the force on y-axis is 18 multiplied by 3, and that is affecting our jump as well. This will only affect the angle of our jump. So to help us with that, we just need to normalize this vector. So in our start function, just write wall jump angle dot normalize. Once we do that, this value just get normalized, meaning right now it's 1 and 3, right? But when I hit play, what's going to happen is it's going to be 0. something something and 0.94. This in turn will not affect our force. So now I'm wall sliding again, and when I jump, it is jumping. Actually, it is jumping. The reason why you can't see a good jump is, but I don't know how to explain that, but it's the reason because why is that? Where did it go? Because of this. This line of code literally just dampens your add force. This add force value just gets dampened by, where did it go? This line of code. So to stop that, just what we need to do for now is that if we are grounded, only then the player will move. This brings another problem because once we start jumping, we won't be able to move. For now, our wall jump problem will be solved. So let's go back, hit play, and if I now, as you can see, just press the jump key and it works perfectly. Right, but as you can see, you can also do something like this. Yeah, it works. But you cannot move the player when you're jumping. Now, after we fix that, mostly everything will be done. So let's fix that, right? Else if we are on the air. So when we're on the ground, we move. Now when we're on the air, that means we are not grounded and we are not touching or just sliding on the wall. So, right, so we are not sliding. So if we're on the air and we are not sliding, as well as we are trying to move, that means our x directional input is not equal to 0, right? So when we're not grounded, and we're not wall sliding, that means we're on the air, right? Probably jumping, and we try to move our player, then we'll move our player, but we'll not add velocity, but we'll add force. So we need a rb.add force, which will have a new vector 2. To move it on the air, we should not use our move speed, we'll use something else, which on the top, let's call it air move speed, right? So serialized field, float, air, move speed, which let's set it up as I guess 20 or maybe 30, because we need a lot more. Because we are literally fighting inertia, we will need a lot more. We need a lot more value. Let's go, where did it go? All right, so here we'll just write rb.addForce is equal to new vector 2, and on the x-axis we are going to write air movement speed, which we will multiply by our x directional input, and on the y-axis we don't need to do anything, so just put it 0. For our force mode 2D we don't need to do anything because it's a constant force, so we don't need to write anything. And after doing this, what's going to happen is, let's go back here, the force is 100. Now if I hit play, I'll be able to move the player, but not that much actually. I do have a little bit of control. If I just do this, as you can see, a little bit of control, but not that much of a big control. As you can see, it's not such a big control, only a little bit of control when we are actually wall jumping. So now to bring the control back, what we should do is, the reason why the control is not there is because the rb.velocity, meaning the rigid body's velocity on the x-axis, is now greater than the movement speed. And in this, when you add a force, you have to go against momentum as well. And because of the momentum, you cannot control it properly. This cannot actually overcome momentum quickly enough so that you can control the player. So to do that, basically just write if and write mathf dot absolute, and inside the bracket write rb dot velocity dot x is now greater than the movement speed if your rigid body's velocity, no matter if it is positive or negative, that's why we used absolute, that gives us a positive value no matter what, is greater than the movement speed, then this will take over. All right, we will use velocity to change the movement of our player. All right, so what will happen is when you're just jumping and trying to control it, our rigid body takes in, and that's why our, where did it go? This takes in. This does not get dampened by our this, but once the velocity is really high, that means we are far enough, and you will see we can use this and control the player, which just helps us make it more responsive on the air and helps us with our wall jump as well. Now finally, what we need to do is but let me just show you. All right, now when I jump, now I can easily control the player, as you can see. A little bit harder, but kind of easier. Yeah, I can control the player way more easily, and I can do some wall jumps as well. But now the main problem is, see, the wall jump doesn't feel right, and the reason why is, let's say, for me, I personally have a habit of just jumping and then moving the player, but many of you might have a habit of moving and then jumping the player. That means you're touching the left or right key. After that, you try to jump. So let's fix that first of all right? Otherwise, it won't be really responsive, as you can see. Many times, yeah, even I make mistakes. So let's first fix that. So to fix that, all you need to do is this function makes the player flip. So we will tell if it is not wall sliding. So if it is not wall sliding, then we can flip the player. And what's going to happen is when you are on the wall, you can't move. And now I can actually have a really good wall jump. As you can see. So with that said, thank you for watching. I hope you liked the video. Please smash the like button if you like the video. Don't forget to subscribe. Please share it if anyone actually wants to know how to make a proper wall jump. And with that said, again, thank you for watching, and bye-bye.